On February 14, 1990, a spacecraft named Voyager 1 turned its camera back toward the inner solar system and captured an image that would change how humanity sees itself. From a distance of roughly 6 billion kilometers, Earth appeared as a tiny speck of light, a pale blue dot, suspended in a sunbeam, barely visible against the vast darkness of space. The person who had requested this photograph, who convinced NASA to turn the spacecraft around for one final look homeward, was an astronomer named Carl Sagan. His reflection on that image would become one of the most profound meditations on human existence ever written. Carl Sagan was not merely an astronomer, though his scientific credentials were substantial and his contributions to planetary science were significant. He was something rarer and perhaps more valuable. A scientist who could communicate the wonder of discovery to people who had never studied science, who could translate the language of research into poetry that moved millions. His voice, both literally and figuratively, carried the message of cosmic perspective to a generation that had grown up watching humans walk on the moon and was ready to think about what might lie beyond. You're watching the Drowsy Astronaut, where tonight we explore the life of a man who spoke for Earth, who believed that the universe was not only comprehensible but worth comprehending, and who dedicated his life to sharing that belief with anyone who would listen. This is a story of curiosity cultivated into expertise, of expertise transformed into communication, of one person's conviction that science belongs to everyone. Let us begin. The significance of Carl Sagan extends beyond any single achievement, any single book or television program or scientific paper, though each of these would be notable on its own. He represents something about the relationship between science and the public, a demonstration that complex ideas need not be simplified into inaccuracy to be shared, that wonder and rigor can coexist, that the universe revealed by careful investigation is more marvelous than any myth. Born in 1934 in Brooklyn, New York, Sagan would become the most famous scientist of his generation. Recognized on streets and in airports, his face familiar to people who could not name another living researcher. This fame was not accidental, but earned through deliberate effort to reach audiences that science had traditionally ignored. He believed that in a democracy increasingly shaped by scientific and technological issues, citizens needed to understand science to govern themselves wisely. His career spanned the space age from its earliest days through the robotic exploration of the outer solar system, and he contributed to missions that visited Venus, Mars, Jupiter, Saturn, and beyond. Investigated the possibility of life on Mars before rovers rolled across its surface, and helped establish the search for extraterrestrial intelligence as a legitimate scientific endeavor rather than a fringe enthusiasm. The television series Cosmos, which premiered in 1980, brought Sagan into living rooms around the world, introducing hundreds of millions of viewers to the story of science and the scientists who pursued it. His books sold millions of copies and remained in print decades after their publication, continuing to find new readers who discovered in them the same sense of wonder that had motivated their author. His voice, gentle and enthusiastic, became synonymous with the excitement of discovery. Yet Sagan was not without critics, both during his lifetime and after. Some scientists resented his fame, feeling that he prioritized publicity over research. that his communication work detracted from more serious scientific pursuits. Others found his confidence in the search for extraterrestrial life premature, his optimism about humanity's future naive, his public positions on nuclear weapons and other political issues inappropriate for a scientist. These criticisms, whatever their merit, could not diminish the impact he had on public understanding of science. The generations of researchers who cite cosmos as the spark that ignited their curiosity. The millions of ordinary people who looked at the night sky differently because of something he wrote or said. Science communication is now recognized as a vital activity, with dedicated careers and university programs. And Sagan was its most successful modern practitioner. His approach was distinctive for its combination of genuine expertise and accessible presentation, avoiding both the condescension that sometimes mars popular science and the obscurity that often keeps academic science from reaching general audiences. He assumed his listeners were intelligent people who simply lacked specialized training, capable of understanding complex ideas if those ideas were explained clearly. This respect for his audience was reciprocated in their enthusiasm for his work. The pale blue dot that Voyager captured at his request became a symbol of his philosophy, the recognition that our world is small and fragile in the cosmic context, that we are all in this together, that the boundaries dividing us are less significant than the planet we share. This perspective, simultaneously humbling and inspiring, characterized Sagan's approach to both science and life, and it resonates still with those who encounter his work. Sagan died in 1996, more than a quarter century ago, yet his influence shows no sign of fading. New versions of Cosmos have introduced his approach to new generations, while his original series remains available and still finds audiences who discover its wonders for the first time. His books continue to sell, his quotations circulate widely, and his name remains associated with the excitement of scientific discovery. The story we will tell tonight traces the arc of this remarkable life. From a curious child in Brooklyn to a professor at Cornell, from a researcher studying planetary atmospheres to a celebrity appearing on talk shows. Carl Sagan believed that we are a way for the cosmos to know itself, that the atoms composing our bodies were forged in ancient stars, that our capacity for wonder is the universe's capacity for wonder expressing itself through us. This belief informed everything he did, from technical research papers to television appearances, from advocacy for nuclear disarmament to speculation about extraterrestrial life. His legacy lives on in every scientist who takes time to explain their work to non-specialists, in every person who looks up at the stars and feels connected to something larger than themselves. The child who would grow up to explain the universe to millions was born on November 9th, 1939, in Brooklyn, New York, to parents who were not scientists, but who would prove remarkably supportive of their son's unusual interests. Samuel Sagan worked in the garment industry, while Rachel Molly Gruber Sagan was a homemaker, whose own intellectual ambitions had been constrained by the limited opportunities available to women of her generation. Together, they would nurture a curiosity that distinguished their son from an early age. Brooklyn in the 1930s was a place of tenements and streetcars, of immigrant communities maintaining old world traditions while adapting to the new world's opportunities. The Sagan family was Jewish, though not particularly observant, part of a generation that was assimilating into American life while retaining cultural connections to their Eastern European heritage. The young Carl grew up speaking English, attending public schools, and absorbing the democratic ideals that would later inform his conviction that science belonged to everyone. The 1939 World's Fair, held in New York City when Carl was 4 years old, made a lasting impression on the future scientist. Time capsules buried at the fair, meant to be opened thousands of years in the future, may have planted seeds for Sagan's later work on interstellar messages. The fair presented a vision of the future shaped by science and reason, a world of sleek machines and abundant energy, of problems solved through human ingenuity rather than conflict or superstition. This technological optimism, tempered by the horrors of the 20th century that would soon unfold, remained a current in Sagan's thinking throughout his life. He believed that science could help humanity, even as he recognized the dangers of technology without wisdom. Young Carl was drawn to the stars from an early age, asking questions about the night sky that his parents could not answer, but did not dismiss. Could there be other worlds out there? Other beings looking back at Earth? These questions, unanswerable at the kitchen table, sent him to libraries where books could provide what family could not. The Brooklyn Public Library became a sanctuary for the curious child, a place where questions led to more questions, where each answer opened new territories for exploration. He read voraciously and widely, consuming science fiction alongside science fact, allowing his imagination to soar while grounding it in what was actually known. This combination of imagination and discipline would characterize his mature work. The willingness to speculate, constrained by commitment to evidence. Science fiction of the 1940s introduced Sagan to the idea of extraterrestrial life, to the possibility that the universe might be populated with civilizations, to visions of humanity's future among the stars. Authors like Edgar Rice Burroughs, who wrote adventure stories set on Mars, and later more rigorous writers like Isaac Asimov and Arthur C. Clarke, shaped his sense of what was possible. The line between science and science fiction would remain productively blurred throughout his career. His parents, recognizing that their son's interests exceeded their ability to nurture them directly, took him to museums and planetariums, exposing him to the wider world of organized knowledge that awaited beyond the family apartment. The Hayden Planetarium in Manhattan became a particular favorite, its dome showing the night sky as it would appear without the interference of city lights, revealing stars that Brooklyn's streets concealed. The Sagan household was not wealthy, but it valued education and self-improvement, the traditional pathways by which immigrant families hoped to advance in America. Rachel Sagan had ambitions of her own that circumstances had prevented her from pursuing, and she invested those hopes in her children, particularly in the son whose exceptional abilities were apparent from early childhood. She could be demanding, sometimes overbearing, but her expectations pushed Carl toward excellence. Samuel Sagan provided a different kind of support, more easygoing than his wife, offering encouragement without pressure. He worked long hours to support the family, missing much of his son's daily life, but he respected the intellectual pursuits that were leading Carl in directions he himself had never traveled. The combination of maternal ambition and paternal acceptance created an environment where exceptional ability could flourish. The young Carl was not only curious, but unusually confident in his curiosity. willing to pursue questions that others might have accepted as unanswerable. He did not assume that the mysteries of the universe were beyond human comprehension, but instead approached them as problems to be solved, territories to be mapped, wonders to be understood. This confidence, bordering sometimes on arrogance, would serve him well in a scientific career that required persistence in the face of uncertainty. High school found Sagan already oriented towards science, his interests crystallizing around astronomy and the question of life on other worlds. He was an excellent student, particularly in science and mathematics, though he also showed ability in writing and speaking that would later prove as valuable as his technical skills. The teenager who graduated from Rahway High School in New Jersey, where the family had moved, was already recognizable as the adult he would become. The influences of childhood would echo throughout Sagan's career, the library visits prefiguring his commitment to public education, the science fiction reading anticipating his work on extraterrestrial life, the planetarium trips foreshadowing his own efforts to bring the night sky into people's lives. He often spoke of his childhood curiosity as something to be preserved rather than outgrown, a quality that too many adults had surrendered. The questions that 4-year-old Carl asked at the World's Fair about the future of humanity and the possibilities of technology remained his questions as an adult, refined by education and experience, but fundamentally unchanged. He never stopped wondering about the universe and humanity's place in it, never stopped believing that these questions mattered and that answers were possible. The child from Brooklyn who read about Mars in the public library would grow up to work on missions that actually visited Mars, to speculate rigorously about the conditions that might allow life to exist there, to write both scientific papers and popular books about the Red Planet. The connection between childhood wonder and adult achievement was direct and unbroken. This continuity between the child and the man was something Sagan valued and sought to encourage in others. He believed that the sense of wonder that children naturally possess should be cultivated rather than extinguished, that the questions they ask are often the most profound questions, that curiosity is not a phase to be outgrown, but a capacity to be developed. His work aimed to reawaken wonder in adults who had forgotten how to ask questions. The University of Chicago, where Carl Sagan arrived in 1951 at the age of 16, was renowned for its commitment to rigorous undergraduate education and its willingness to admit students younger than traditional college age. The institution's core curriculum exposed students to great works across all fields of knowledge, creating the kind of broadly educated mind that Sagan would later bring to his communication work. Here he encountered not just science, but philosophy, history, and literature. Chicago's intellectual atmosphere was intense and challenging, demanding serious engagement with difficult ideas and offering little patience for superficiality. The young Sagan thrived in this environment, his confidence validated by the recognition he received from professors and peers. He found himself among other exceptional students, many of whom would go on to distinguished careers of their own, creating a community of intellectual ambition that pushed him to excel. His formal education in astronomy began at Chicago, though his informal education had begun years earlier in Brooklyn libraries. Now he learned the mathematics and physics that underlay astronomical observations, the techniques by which scientists converted points of light into knowledge about distant objects. The romantic vision of the night sky that had captivated his childhood was joined by the technical apparatus necessary to understand it scientifically. The transition from amateur enthusiasm to professional training is not always easy, as the poetry of the stars meets the prose of equations and observations. Some students lose their wonder when confronted with the technical details, finding that the magic disappears when examined too closely. Sagan was not among them. For him, understanding the mechanisms deepened, rather than diminished the wonder, revealing new layers of marvel within what had seemed already marvelous. After completing his undergraduate degree, Sagan remained at Chicago for graduate work, pursuing a doctorate in astronomy and astrophysics that would establish his credentials as a serious researcher. His dissertation advisor was Gerard Kuiper, a Dutch-American astronomer who was among the leading planetary scientists of his generation. Under Kuiper's guidance, Sagan learned to apply physical principles to understanding the conditions on other worlds. The focus of Sagan's doctoral research was the atmosphere and surface of Venus, a planet that was poorly understood in the 1950s and early 60s. Observations suggested that Venus was covered by thick clouds, but what lay beneath those clouds remained mysterious. Some scientists imagined swampy jungles, others arid deserts, others world-spanning oceans. The truth was far more extreme than any of these guesses. Sagan's analysis of radio emissions from Venus, combined with theoretical modeling of atmospheric physics, led him to conclude that the surface of Venus was extraordinarily hot, perhaps 400 degrees Celsius or more. This heat resulted from an extreme greenhouse effect, with the thick carbon dioxide atmosphere trapping solar energy and raising temperatures far beyond what distance from the sun alone would predict. This conclusion, controversial at the time, would be confirmed by later spacecraft observations. The Venus work established Sagan as a planetary scientist to be taken seriously, someone who could combine observations with theoretical understanding to reach conclusions about distant worlds. It also introduced him to the concept of the greenhouse effect, which would later inform his thinking about Earth's climate and the dangers of human activities that might alter it. Following his doctorate, Sagan pursued postdoctoral work at the University of California, Berkeley, where he continued his research on planetary atmospheres while also beginning to explore the possibility of life on other worlds. The early 1960s was a time of excitement in planetary science, as the space age was making direct exploration of other worlds possible for the first time. His interests were broad, encompassing not just astronomy, but biology, chemistry, and the history and philosophy of science. This breadth would later distinguish his communication work, allowing him to connect specialized topics to larger themes and to address audiences whose interests extended beyond any single discipline. He was never content to remain within the boundaries of any one field. At Berkeley, Sagan began working with Joshua Lederberg, a Nobel laureate in genetics who was interested in the possibility of extraterrestrial life. This collaboration introduced Sagan to the emerging field of exobiology, the study of life beyond Earth, and helped legitimate his interest in a topic that many scientists considered too speculative for serious research. Lederberg's imprimatur gave cover for investigations that might otherwise have been dismissed. The combination of planetary science and exobiology would define Sagan's research agenda for the rest of his career. He was interested not just in the physical conditions on other worlds, but in whether those conditions might permit life, not just in the abstract possibility of extraterrestrial life, but in the specific environments where it might actually exist. This focus gave his work a coherence and direction that connected disparate projects. In 1968, Sagan joined the faculty of Cornell University in Ithaca, New York, where he would remain for the rest of his career. Cornell provided an institutional home for his increasingly diverse activities, supporting his research while also tolerating, if not always enthusiastically supporting, his growing public profile. He became director of the Laboratory for Planetary Studies and associate director of the Center for Radiophysics and Space Research. At Cornell, Sagan supervised graduate students, taught courses, and continued his research on planetary atmospheres and the search for life. He was known as an inspiring teacher who could communicate complex ideas with clarity and enthusiasm, though his growing commitments outside the university sometimes limited his availability to students. His lectures, like his later television appearances, combined scientific content with broader reflections on the meaning and importance of what was being learned. The scientific papers he published during these years addressed topics ranging from the organic chemistry of planetary atmospheres to the possibility of life on the moons of Jupiter. He contributed to the design of experiments for Mars landers, helped interpret data from missions to various planets, and wrote technical analyses that were respected by specialists in the field. His scientific credentials were genuine, whatever critics might later say about his public activities. The transition from promising young scientist to established researcher to public figure occurred gradually over these years, each stage building on what came before. The scientist who would eventually host Cosmos was first a serious researcher, someone who'd earned the right to speak authoritatively about the cosmos through years of careful work. The celebrity was built on a foundation of genuine expertise. The question that had fascinated Carl Sagan since childhood, whether life existed beyond Earth, became the organizing theme of much of his scientific career, lending coherence to research that might otherwise have seemed scattered across unrelated topics. Every study of planetary atmospheres, every analysis of organic chemistry, every investigation of extreme environments connected to this central concern, the search for extraterrestrial life in the 1960s was not yet the respectable scientific endeavor it would later become. Regarded by many researchers as too speculative, too tainted by science fiction associations, too unlikely to produce definitive results within reasonable timescales, Sagan was instrumental in changing this perception, bringing scientific rigor to questions that had previously been left to dreamers and novelists. His approach was simultaneously imaginative and disciplined, willing to consider possibilities that others dismissed while insisting on evidence and logical reasoning as the basis for conclusions. He could speculate about Martian organisms or the inhabitants of Jovian clouds, but his speculations were grounded in what was known about chemistry and physics, constrained by the actual conditions that prevailed on other worlds. The Miller-Urey experiment of 1953, which had demonstrated that amino acids could form spontaneously under conditions thought to resemble early Earth, suggested that the chemistry of life might arise naturally given appropriate conditions. Sagan pursued similar investigations, exploring what organic chemistry might occur on other worlds with different atmospheric compositions and energy sources. His experiments on the synthesis of organic molecules under conditions simulating the atmospheres of Jupiter and Titan demonstrated that complex chemistry was possible, even in environments very different from Earth. Brownish organic residues formed in laboratory flasks, suggesting that similar processes might create organic layers in the atmospheres of the outer planets. These tholins, as Sagan named them, might represent a kind of pre-biological chemistry occurring throughout the solar system. The question of life on Mars particularly fascinated Sagan, connecting to his childhood reading about the red planet, while engaging with the real scientific questions that spacecraft exploration was beginning to address. When the Mariner missions revealed Mars to be a cratered, apparently lifeless desert rather than the canal-crossed civilization of science fiction, Sagan was disappointed, but not discouraged. He argued that life might exist below the Martian surface, or might have existed in the past when conditions were more favorable, or might exist in isolated environments that had not yet been examined. The absence of evidence was not evidence of absence, he maintained, particularly when so little of Mars had been directly investigated. This hopeful skepticism characterized his approach to the search for life. When the Viking missions landed on Mars in 1976, Sagan was deeply involved, having contributed to the design of experiments intended to detect biological activity, if any existed. The results were ambiguous, with some tests suggesting possible biological activity, while others indicated purely chemical explanations. The scientific consensus eventually settled on the conclusion that no life had been detected, but Sagan remained open to alternative interpretations. The search for extraterrestrial intelligence, known by the acronym SETI, represented another dimension of Sagan's interest in life beyond Earth. While the search for microbial life focused on environments within our solar system, SETI looked farther, to the possibility of technological civilizations around other stars that might be detectable through the signals they intentionally or unintentionally produced. Sagan helped establish SETI as a legitimate scientific endeavor, arguing that the question of whether we are alone in the universe was profound enough to justify serious investigation, even if the probability of success was uncertain. He participated in conferences, wrote papers, and advocated for SETI programs at a time when many scientists considered the effort premature or misguided. The Drake equation, formulated by astronomer Frank Drake in 1961, provided a framework for estimating the number of detectable civilizations in our galaxy. Sagan often discussed this equation, which multiplied together factors including the rate of star formation, the fraction of stars with planets, the fraction of planets where life arises, the fraction where intelligence evolves, and the lifetime of technological civilizations. Each factor was uncertain, but the exercise helped structure thinking about the problem. Sagan was generally optimistic about the prospects for extraterrestrial intelligence, believing that life was likely to arise wherever conditions permitted, and that intelligence, once arisen, would prove adaptive enough to be common. This optimism was tempered by uncertainty about the lifetime of technological civilizations, the possibility that most destroyed themselves before becoming detectable across interstellar distances. His scientific work on extraterrestrial life was accompanied by more speculative explorations in essays and popular writings, where he could consider possibilities that rigorous scientific papers could not entertain. He imagined what alien life might look like, how extraterrestrial intelligence might differ from human intelligence, what forms communication with other civilizations might take. These speculations were always informed by scientific knowledge, constrained by what was physically and chemically possible, but they allowed his imagination fuller range than technical papers permitted. The line between Sagan the scientist and Sagan the visionary was permeable, each role informing the other in productive ways. The search for life beyond Earth connected to Sagan's broader concerns about humanity's future, the possibility that studying other civilizations might reveal something about our own prospects. If many civilizations self-destructed shortly after developing dangerous technologies, this would suggest a warning for humanity. If some civilizations survived for millions of years, this would offer hope that survival was possible. This cosmic perspective on human affairs, viewing our situation as one instance of a potentially common phenomenon, characterized Sagan's approach to many issues. The same mind that could contemplate life on distant worlds could also contemplate nuclear war or environmental destruction, seeing these as challenges that any technological species might face. The search for extraterrestrial life was also, in a sense, a search for understanding of ourselves. In 1972, the Pioneer 10 spacecraft was prepared for launch on a trajectory that would carry it past Jupiter and eventually out of the solar system entirely, becoming the first human artifact to leave the realm of the planets. Carl Sagan recognized an opportunity that others had not considered: the chance to send a message to whoever might someday find the spacecraft drifting through interstellar space. Working with fellow astronomer Frank Drake and artist Linda Salzman Sagan, who was then his wife, Carl designed a small plaque to be attached to the spacecraft, a message in a bottle cast into the cosmic ocean. The plaque depicted a man and woman standing beside the spacecraft for scale, a diagram of the solar system showing where the spacecraft originated, and a schematic representation of hydrogen atoms providing a universal unit of measurement. The design of the plaque raised immediate questions about what to include and what to exclude. How to communicate with beings who shared no language, no cultural references, no assumptions about the universe beyond the physics and chemistry that presumably governed everywhere. The challenge was to encode information in a form that intelligent recipients could decode without any prior knowledge of human civilization. The hydrogen atom schematic was particularly clever, using the spin-flip transition of hydrogen as a clock that any technologically capable species should recognize. This provided a unit of time and length that could calibrate other elements of the message. The location of the Sun was indicated relative to 14 pulsars, rapidly spinning neutron stars, whose precise periods would allow the Sun to be identified from anywhere in the galaxy. The Pioneer plaque attracted considerable public attention when it was announced, including some criticism of the nude figures depicted on it. The image of the naked human beings was meant to convey what humans looked like to recipients who had never seen one. But some commentators found it inappropriate, objecting to what they called pornography being sent into space. Sagan defended the design as scientifically appropriate, representing humanity as we actually appeared. When the Voyager spacecraft were prepared for launch in 1977, Sagan had an opportunity to create a more elaborate message. The Voyager Golden Records were phonograph records containing sounds and images of Earth, a far richer representation of human civilization than the simple plaques carried by Pioneer. Sagan chaired the committee that decided what to include. The selection process was both challenging and revealing, forcing the committee to decide what aspects of human experience best represented our species to unknown recipients. The records ultimately included greetings in 55 languages, music from around the world, natural sounds from Earth, and 116 images depicting everything from human anatomy to scientific diagrams to photographs of daily life. The musical selections ranged from Bach to Beethoven to Chuck Berry, from Azerbaijani bagpipes to Peruvian panpipes, from Senegalese percussion to Australian Aboriginal songs. The choices reflected both Western classical traditions and a deliberate effort to represent the full diversity of human musical expression. Each selection had to convey something about humanity to listeners who knew nothing about us. Anne Druyan, who served as creative director of the Golden Record project, would become the love of Sagan's life, though they were both married to others when they began working together. Their collaboration on the Voyager message led to a romance that transformed both their lives, eventually resulting in marriage after both had divorced their previous spouses. The story of their love became intertwined with the story of the messages they sent to the stars. Druyan's contribution to the Golden Record included the decision to record her brainwaves and have them encoded on the record. A meditation on what it felt like to be human that might, in principle, be decoded by sufficiently advanced recipients. She recorded these brainwaves while thinking about the history of Earth, the human predicament, and her newly discovered love for Carl Sagan. The recording was made just days after they declared their feelings for each other. The Golden Records were designed to last for hundreds of millions, or even billions of years, in the vacuum of interstellar space, far outlasting any human artifact on Earth. Long after human civilization has vanished, whether through self-destruction or transformation into something unrecognizable, the Voyager spacecraft will continue their silent journey, carrying their messages to destinations they will reach in tens of thousands of years. The messages were always more about us than about potential recipients. Expressions of hope that humanity would be remembered, that the best of what we are might survive, even if we ourselves did not. Sagan understood this symbolic dimension of the project, while also taking seriously the scientific and philosophical challenges of interstellar communication. The spacecraft carrying these messages are now in interstellar space, having crossed the boundary where the sun's influence gives way to the currents of the wider galaxy. Voyager 1, the more distant of the two, is roughly 24 billion kilometers from Earth, still transmitting data, though its power supply grows weaker year by year. Eventually, the transmissions will cease, and the spacecraft will continue in silence. The probability that any intelligent beings will ever find the Voyager spacecraft is extremely small, given the vastness of interstellar space and the limited volumes the spacecraft will traverse, even over millions of years. Sagan knew this, but argued that the exercise was worthwhile anyway, that the attempt to communicate across cosmic distances was meaningful regardless of its likely failure. Creating the messages forced humanity to think about how we would represent ourselves. What we value, what we hope to be remembered for. The process of selection was itself valuable, prompting reflection on what matters most about human experience. Even if no one ever finds the records, the exercise of creating them had value for those who created them. The golden records represent a kind of optimism that characterized Sagan's worldview. The belief that the universe is worth exploring, that communication is worth attempting, that hope is warranted even in the face of overwhelming odds. This optimism was not naive, but deliberate, a choice to affirm possibility rather than surrender to probability. In 1980, a television series premiered that would change how millions of people thought about science, the universe, and their place within it. Cosmos, A Personal Voyage, hosted and co-written by Carl Sagan, became the most widely watched series in the history of American public television, eventually reaching an estimated audience of over 500 million people in 60 countries. Nothing like it had been attempted before on such a scale. The series was produced by KCET in Los Angeles, with Sagan working alongside his wife Anne Druyan and astronomer Stephen Soter as co-writers. The production was ambitious, requiring travel to locations around the world, innovative special effects that pushed the boundaries of what television could accomplish, and a narrative approach that wove together science, history, philosophy, and poetry into a coherent vision. Sagan himself was the constant presence throughout the 13 episodes, walking viewers through the history of astronomy, the origin of life, the structure of the cosmos, and the prospects for humanity's future. His presentation style was distinctive, combining genuine enthusiasm with a gentle, almost intimate manner that made complex ideas feel accessible. He spoke to viewers as intelligent adults who simply lacked specialized training, never condescending, but never obscuring. The series opened with Sagan's famous declaration that the cosmos is all that is, or was, or ever will be, establishing from the first moments that the subject matter would extend beyond conventional science programming to address fundamental questions about existence. The scope was deliberately vast, encompassing not just facts about the universe, but reflections on what those facts meant for human self-understanding. Each episode of Cosmos addressed a different aspect of the cosmic story, from the origin of life on Earth to the search for extraterrestrial intelligence, from the history of astronomical discovery to the fate of the universe billions of years in the future. The progression was roughly chronological, tracing the emergence of complexity from the simplicity of the early universe. But the narrative also moved back and forth through time, connecting present understanding to past discovery. The production made extensive use of a device Sagan called the Ship of the Imagination, a spacecraft of the mind that carried viewers to locations impossible to visit physically. Through special effects that were state-of-the-art for their time, viewers traveled to the surface of Venus, the rings of Saturn, the center of the galaxy, and the edge of the observable universe. The device was both pedagogical and poetic, emphasizing that imagination was humanity's vehicle for exploring what could not be reached in person. Sagan's personal engagement with the material was evident throughout. His fascination with the subjects he discussed communicating itself to viewers who might have found the same information dry in other presentations. He spoke of historical figures like Johannes Kepler and Hypatia of Alexandria, with evident admiration, making them come alive as human beings rather than names in textbooks. The series did not shy away from addressing controversial or philosophical topics, including the danger of nuclear war, the environmental challenges facing civilization, and the religious implications of scientific cosmology. Sagan believed that science had implications beyond the laboratory, that understanding the universe carried responsibilities for how we lived within it. This conviction gave the series a moral dimension that distinguished it from mere science education. The impact of Cosmos extended far beyond its initial broadcast, continuing through book sales, home video releases, and eventually streaming availability that introduced the series to new generations. Scientists who were children when the series aired often cite it as the inspiration for their careers, the spark that ignited interests that would define their lives. The series created scientists as well as informing the public. The companion book, also titled Cosmos, became a bestseller that remained in print for decades, offering a written version of the series' content that could be absorbed at the reader's own pace. Sagan's writing style, like his speaking style, combined clarity with eloquence, making scientific concepts accessible while maintaining their profundity. The visual effects that seemed impressive in 1980 inevitably dated as technology advanced, leading to concerns that the series would lose its relevance as newer, flashier productions became available. Yet viewers continued to find value in the original Cosmos, responding to qualities that transcended production values. The quality of Sagan's explanations, the breadth of his vision, the sincerity of his engagement. In 2014, a new version of Cosmos premiered, hosted by astrophysicist Neil deGrasse Tyson and produced with Androian's involvement, updating the original's content and visuals for a new generation. The new series acknowledged its debt to the original, while addressing topics that had advanced since Sagan's time. The fact that a new Cosmos was deemed necessary demonstrated the enduring power of the original concept. The success of Cosmos made Sagan a celebrity in a way that few scientists had ever been. Recognizable on the street, invited to appear on talk shows, sought for commentary on any topic related to science or space. This fame was a mixed blessing, enhancing his ability to communicate, while also attracting criticism from colleagues who felt he was neglecting research for publicity. Sagan accepted the trade-offs that fame entailed, believing that the opportunity to reach millions of people with scientific ideas justified the compromises required. He continued his research and maintained his academic position, but an increasing portion of his time went to public communication. The scientist and the communicator coexisted, though not always comfortably. The criticism from within the scientific community sometimes wounded Sagan, who valued the respect of his colleagues, even as he pursued activities they often disdained. He was twice denied membership in the National Academy of Sciences, despite his scientific accomplishments, rejections that many attributed to resentment of his popular success. The scientific establishment was not always comfortable with scientists who became famous. Yet the impact of Cosmos on public understanding of science was undeniable. And that impact was Sagan's vindication. Whatever his colleagues thought, he had accomplished something that no amount of technical research could have achieved. He had made millions of people care about science, had shown them that the universe was worth understanding, had given them a glimpse of cosmic perspective. Beyond television, Carl Sagan reached audiences through books that combined scientific accuracy with literary grace. Works that demonstrated his ability to communicate complex ideas in written form as effectively as he did on screen. His bibliography includes both technical publications for specialists and popular works for general audiences, with the latter reaching far more readers and establishing his reputation as a writer. The Dragons of Eden, published in 1977, explored the evolution of human intelligence, tracing the development of the brain from its earliest evolutionary origins to its current complexity. The book ranged across neuroscience, evolutionary biology, psychology, and philosophy, drawing connections that illuminated each field while remaining accessible to non-specialists. It won the Pulitzer Prize for General Nonfiction in 1978, recognizing its literary as well as scientific merit. The book's title referred to a metaphor for the ancient reptilian portions of the human brain that coexist with more recently evolved structures, suggesting that human nature is a composite of different evolutionary stages. Sagan explored how this evolutionary heritage shaped human behavior, including both our capacity for reason and our tendencies toward aggression and irrationality. Broca's Brain, published in 1979, took its title from the preserved brain of Paul Broca, a 19th-century anatomist who identified the brain region responsible for speech. The book was a collection of essays addressing topics ranging from the search for extraterrestrial intelligence to the debunking of pseudoscience, demonstrating the range of Sagan's interests and the consistency of his commitment to rational inquiry. The Cosmic Connection, published in 1973, was an earlier work that anticipated many of the themes Sagan would develop more fully in Cosmos. The book explored humanity's relationship to the universe, the search for extraterrestrial life, and the prospects for space exploration, presenting scientific content within a framework of philosophical reflection. After the television series, the book version of Cosmos became one of Sagan's most successful works, spending 70 weeks on the New York Times bestseller list and becoming the best-selling science book ever published in the English language at that time. The book extended and deepened the material presented in the series, allowing readers to absorb the information at their own pace. Contact, published in 1985, was Sagan's only novel, a work of science fiction that drew on his scientific expertise to imagine humanity's first encounter with extraterrestrial intelligence. The protagonist, Ellie Arroway, was a radio astronomer who detected a signal from an alien civilization, and the story explored the scientific, political, and personal implications of such a discovery. The novel reflected Sagan's thinking about what contact with extraterrestrial intelligence might actually be like, drawing on his years of research and speculation to create a scenario that was scientifically plausible while remaining dramatically compelling. The story addressed themes of science and religion, skepticism and wonder, individual vision and institutional resistance. Contact was adapted into a major film in 1997, released the year after Sagan's death and starring Jodie Foster as Ellie Arroway. Sagan had been involved in the development of the film, working on the screenplay with Anne Druyan before his health failed. The movie brought his ideas to an even wider audience, though it necessarily simplified and altered elements of the novel. The Demon-Haunted World, published in 1998, was Sagan's most direct statement about the importance of scientific thinking and the dangers of irrationality and superstition. The book argued for scientific literacy as essential to democracy, contending that citizens needed to understand science to make informed decisions about the increasingly technological issues facing society. The book's subtitle, Science as a Candle in the Dark, captured Sagan's sense of science as illumination against the darkness of ignorance and unreason. He discussed critical thinking tools that could help people evaluate claims. The same skills that scientists used in their work, but that were valuable for anyone navigating a world full of dubious assertions. Pale Blue Dot, published in 1994, took its title from the famous photograph Sagan had requested from Voyager, using that image as a launching point for reflections on humanity's place in the cosmos and prospects for the future. The book advocated for continued space exploration, not as an escape from Earth's problems, but as an expression of the same curiosity that had driven human exploration throughout history. The quality that distinguished Sagan's writing was his ability to combine scientific content with literary elegance, to make accurate statements about the natural world, while also making them beautiful. He did not believe that clarity required sacrificing complexity or that accessibility meant dumbing down. His sentences were carefully crafted to carry both meaning and rhythm. His famous reflection on the pale blue dot exemplifies this quality. Building through a series of observations about Earth's appearance in the photograph to a meditation on human significance and responsibility. The passage has been quoted countless times, used in speeches and videos and commemorations, because it captures something true in language that is also moving. Sagan wrote with passion, but also with precision, allowing his enthusiasm for his subjects to show while maintaining the accuracy that his scientific training demanded. The combination was rare, as most scientists who wrote for popular audiences erred either toward dryness or toward sensationalism. Sagan found a middle path that served both truth and engagement. His books remain in print decades after their publication, continuing to find readers who discover in them the same sense of wonder that motivated their author. Libraries still stock them, teachers still assign them, and people still give them as gifts to young people whose curiosity is awakening. The writer lives on in his words. Carl Sagan believed that scientists had a responsibility to engage with public issues, particularly those where scientific understanding could inform important decisions about humanity's future. This conviction led him beyond the classroom and the laboratory into the realm of political advocacy, where his fame gave him a platform and his expertise gave him credibility. The issue that most urgently concerned him was the threat of nuclear war, which during the Cold War seemed to many observers like a genuine possibility that could end human civilization. Sagan brought his scientific skills to bear on understanding the consequences of nuclear weapons, contributing to research that revealed previously unrecognized dangers. In the early 1980s, Sagan and several colleagues developed the concept of nuclear winter, the theory that a large-scale nuclear war would inject so much smoke and dust into the atmosphere that global temperatures would drop catastrophically. The resulting cold and darkness could kill more people than the initial explosions, potentially threatening human extinction. The nuclear winter research grew out of studies of Martian dust storms, and volcanic eruptions on Earth, applying atmospheric science to a question of urgent practical importance. Sagan and his colleagues published their findings in scientific journals and also communicated them directly to the public, believing that this was a case where public understanding could influence policy. The nuclear winter hypothesis was controversial, with some scientists questioning the modeling assumptions and others concerned that the public advocacy was compromising scientific objectivity. Sagan defended both the science and the advocacy, arguing that the stakes were too high for scientists to remain silent about what their research revealed. He testified before Congress, appeared on television, wrote articles for popular magazines, and participated in debates with those who downplayed the nuclear threat. His willingness to engage in public controversy was unusual for a scientist of his stature, and it won him both admiration and criticism depending on the audience. The political implications of the nuclear winter research were clear. It suggested that even a limited nuclear war could have catastrophic global consequences, strengthening the case for arms reduction and disarmament. Sagan did not shy away from these implications, arguing that scientists had a responsibility to speak out when their research revealed existential threats. His advocacy extended beyond nuclear weapons to environmental issues, including climate change and the depletion of the ozone layer. He recognized that the same atmospheric science that revealed the dangers of nuclear winter also revealed the dangers of human-caused climate change, and he spoke about both with similar urgency. Sagan promoted scientific literacy as essential for democracy, arguing that citizens needed to understand science to evaluate the claims of politicians, advertisers, and advocates of various causes. In a world increasingly shaped by technology and threatened by technological dangers, scientific ignorance was not merely unfortunate, but dangerous. He worried about the decline of science education, the spread of pseudoscience and superstition, and the tendency of media to sensationalize or oversimplify scientific findings. His book, The Demon-Haunted World, addressed these concerns directly, offering both a critique of irrationality and a toolkit for thinking clearly about claims of all kinds. The connection between science education and democracy was not abstract for Sagan, but concrete. How could citizens evaluate claims about climate change, nuclear power, or genetic engineering without understanding the science involved? How could they distinguish between legitimate expertise and confident nonsense? Scientific literacy was not a luxury, but a necessity. His advocacy sometimes put him at odds with political authorities who preferred that scientists remain in their laboratories rather than engaging with public debates. Some of his colleagues felt that his political activities compromised his scientific credibility, while others admired his willingness to apply his expertise to issues that mattered. Sagan also advocated for space exploration, not merely as a scientific endeavor, but as a continuation of the human impulse to explore that had carried our ancestors across continents and oceans. He believed that expanding into space was essential for the long-term survival of humanity, ensuring that a single catastrophe could not end our story entirely. This advocacy put him in alliance with those who favored ambitious space programs. Though Sagan was not uncritical of how space exploration was sometimes conducted, he opposed the militarization of space and criticized programs that he felt were more about national prestige than scientific discovery or genuine exploration. His vision of space exploration emphasized robotic probes over crewed missions in the short term, recognizing that robots could explore more territory at lower cost and risk than human astronauts. He supported eventual human expansion into the solar system, but believed the priority should be learning as much as possible about other worlds with the tools currently available. The advocacy for space exploration connected to his broader concerns about humanity's future, the need to think on timescales longer than individual lifetimes or political terms. A species confined to one planet was vulnerable to extinction from any number of causes. A species spread across the solar system would be far more resilient. Throughout his career, Carl Sagan emphasized the importance of skeptical inquiry, the willingness to question claims and demand evidence before accepting conclusions. This skepticism was not cynicism or closed-mindedness, but rather a commitment to honest investigation, a refusal to accept ideas simply because they were attractive or popular. His most famous formulation of this principle was the observation that extraordinary claims require extraordinary evidence, a standard he applied to pseudoscientific claims, paranormal phenomena, and assertions about extraterrestrial visitors. The more remarkable the claim, the stronger the evidence needed to support it. Sagan was frequently asked about UFO sightings, and he addressed the topic with characteristic balance, neither dismissing the possibility of extraterrestrial visitors nor accepting the evidence offered for their presence. He had looked into many UFO reports and found them explicable through conventional means: misidentified aircraft, atmospheric phenomena, hoaxes, or honest misperception. The absence of evidence for extraterrestrial visitors did not prove they did not exist, but it did mean that claims of their presence could not be accepted without better evidence than was currently available. This position disappointed both believers, who wanted him to confirm their experiences, and debunkers who wanted him to dismiss the entire subject with contempt. His skepticism extended to astrology, which he regarded as a pseudoscience with no scientific basis. Popular though it was, he signed a statement by scientists criticizing astrology, though he later expressed some reservations about the statement's tone, which he felt was too dismissive and authoritarian rather than educational. The paranormal in general attracted his critical attention, from claims of psychic powers to reports of miraculous healings to assertions about ancient astronauts building Earth's monuments. In each case, he applied the same standard. What is the evidence? How reliable are the sources? What alternative explanations have been considered? Sagan's approach to these topics was not merely negative, not simply an exercise in debunking. He tried to understand why people believed things that lacked evidential support, recognizing that human cognition was prone to errors that made pseudo-scientific claims attractive. Understanding these cognitive biases was as important as recognizing their effects. The Demon-Haunted World, published near the end of his life, was his most sustained treatment of skeptical thinking, offering what he called a baloney detection kit, tools for evaluating claims of any kind. The tools included seeking independent confirmation, looking for alternative hypotheses, considering the reliability of sources, and distinguishing correlation from causation. Yet Sagan's skepticism was always paired with wonder, a recognition that the universe as revealed by science was more amazing than any pseudo-scientific alternative. He did not debunk in order to diminish, but in order to replace inadequate mysteries with genuine ones, false wonders with real ones. The actual history of life on Earth, he argued, was more marvelous than any creation myth. The actual structure of the atom was more strange than any magical thinking. The actual distances to the stars were more astonishing than any science fiction fantasy. Science revealed wonders that did not require abandoning critical thinking to appreciate. This balance between skepticism and wonder was central to his identity as a scientist and communicator. He showed that it was possible to demand evidence while also embracing mystery, to question claims while also remaining open to surprise. The two attitudes were not in conflict, but were aspects of a single commitment to honest inquiry. His skepticism was sometimes criticized by those who felt he was too quick to dismiss claims that they found compelling, or too confident in the ability of science to address questions that might lie beyond its methods. Sagan acknowledged that science had limitations, but maintained that within its domain it was the most reliable method for understanding the world. The legacy of Sagan's skepticism extends to modern skeptical movements, which often cite him as an inspiration and model. Organizations dedicated to investigating paranormal claims and promoting critical thinking look to him as a predecessor who demonstrated how skepticism could be combined with accessibility and wonder. His insistence on evidence-based thinking remains relevant in an age of misinformation and conspiracy theories, when the skills he tried to teach are needed more than ever. The baloney detection kit he proposed offers tools for navigating a world where false claims spread rapidly through social media and where distinguishing truth from nonsense requires active effort. Yet the spirit of his skepticism was not harsh or judgmental, but educational, aimed at helping people think more clearly rather than making them feel foolish for past beliefs. He approached those who believed in pseudoscience as fellow humans who had been misled rather than as enemies to be defeated. This generous skepticism, combining rigorous standards with genuine respect for those who fell short of them, characterized Sagan's approach to communication generally. He believed people were capable of clear thinking if given the tools and the encouragement, and he devoted much of his career to providing both. In 1990, the Voyager 1 spacecraft was preparing to leave the solar system, its primary mission of photographing the outer planets complete. At Carl Sagan's suggestion, NASA commanded the spacecraft to turn its camera back toward the inner solar system for a final series of images that would capture Earth and other planets from a perspective never before seen. The images were taken on February 14, 1990, Valentine's Day. From a distance of approximately 6 billion kilometers. At this distance, the Sun appeared as merely a bright star, and Earth was barely visible, a pale blue dot, less than a single pixel in size, suspended in a scattered ray of sunlight. The image of Earth from this distance became one of the most famous photographs ever taken, not because of its beauty or technical quality, but because of what it revealed about our planet's place in the cosmos. Here was everything, every person who had ever lived, every love and war and triumph and tragedy, every religion and philosophy, every achievement and failure contained on a tiny point of light. Sagan's reflection on this image often called the pale blue dot speech, remains one of the most profound pieces of science communication ever created. He delivered versions of it in speeches and eventually published an extended reflection in his 1994 book of the same name. The reflection began with the observation of what the image showed: Earth as a mote of dust suspended in a sunbeam, and proceeded to draw out the implications of this perspective. Every person we had ever heard of had lived out their lives on that tiny world, unaware for most of history that their home was a small planet in a vast cosmos. The great conquerors and empires, the martyrs and tyrants, the lovers and enemies, the young couples full of hope, and the old people with fading memories, all had existed on that pale blue dot, the only home we had ever known. The perspective was simultaneously humbling and inspiring, reducing human pretension while also revealing human preciousness. Sagan used the image to comment on the conflicts and cruelties that had marked human history. The rivers of blood spilled by generals and emperors to become momentary masters of a fraction of a dot. The cosmic perspective revealed the folly of these ambitions, the absurdity of fighting over boundaries invisible from any significant distance. Yet the reflection was not despairing, but motivating, using the vulnerability revealed by the image as a reason for greater care rather than resignation. There was no hint of help coming from elsewhere to save us from ourselves. We were responsible for our own fate, and the pale blue dot was the only home we had or were likely to have for a very long time. The image also revealed the rarity and preciousness of Earth in the cosmic context, the only world we knew of that harbored life, a small oasis in the vast darkness of space. Whatever our conflicts and differences, we were all in this together, sharing a fragile world that deserved our protection. Sagan argued that the pale blue dot perspective was not merely humbling, but ennobling, but revealing our responsibility to deal more kindly with one another, and to preserve and cherish the only home we had ever known. The cosmic perspective was not an escape from human concerns, but a deepening of them. The image and Sagan's reflection on it have been widely shared and frequently quoted in the decades since. Used in contexts ranging from environmental advocacy to philosophical education to simple attempts to capture the human condition. The words resonate because they capture something true in language that is also beautiful. The pale blue dot became a symbol of Sagan's entire approach to science and life. The recognition that understanding our cosmic context should inform how we live, that knowledge carries responsibility, that wonder and wisdom can coexist. The image and the reflection it prompted encapsulate his legacy. The perspective offered by the pale blue dot image was not new with Sagan, having been anticipated by astronauts who looked back at Earth from space and felt transformed by what they saw. The overview effect, as this transformative experience was later called, created in some viewers a profound sense of the unity and fragility of Earth. What Sagan contributed was the articulation of this perspective in language accessible to those who would never travel to space. The translation of a visual experience into words that could carry similar meaning. He made the overview effect available to anyone who read or heard his reflection. The image continues to be used as a reminder of our place in the cosmos, appearing in presentations and videos and educational materials around the world. Each use extends Sagan's intention, spreading the cosmic perspective to audiences who may never have heard of him but who absorb the lesson nonetheless. The Voyager spacecraft that took the image continues its journey into interstellar space, still occasionally transmitting data, though its power supplies grow weaker with each passing year. Eventually, it will fall silent, but it will carry the golden record and its messages for millions of years, a testament to human curiosity that may outlast human civilization. Carl Sagan continued working with undiminished intensity through the early 1990s, writing books, making television appearances, and continuing his scientific research. The fame that cosmos had brought him had not diminished, and he remained one of the most recognized scientists in the world, sought for commentary on any topic related to space or science. In 1994, he was diagnosed with myelodysplasia, a disorder of the bone marrow that interferes with the production of blood cells. The diagnosis was serious, potentially fatal, and it came as a shock to someone who had lived with such vitality and seemed to have so much work still to do. The treatment required bone marrow transplants, and Sagan underwent the procedure with his sister Carol as the donor. The transplants were partially successful, giving him additional time, though not curing the underlying condition. He used this time to continue his work, completing books and maintaining his public engagement even as his health declined. Pale Blue Dot was published the year of his diagnosis, and The Demon-Haunted World appeared in 1995, demonstrating that his intellectual powers remained intact even as his body weakened. He continued giving interviews, attending events when his health permitted, and working on projects that would extend his influence beyond his lifetime. The final years also brought personal satisfaction, as his marriage to Anne Druyan proved to be a deep and sustaining partnership. They collaborated on writing projects, shared domestic life in Ithaca, and raised a family together. The love story that had begun with the Voyager Golden Record had matured into a lasting union. Sagan's relationship with the scientific establishment also seemed to soften in his final years, as colleagues who had once criticized his public activities came to appreciate the impact he had made. The criticism never entirely disappeared, but it was increasingly balanced by recognition of his unique contributions. He died on December 20th, 1996, at the age of 62, at the Fred Hutchinson Cancer Research Center in Seattle. His death was mourned around the world, with tributes from scientists, politicians, and ordinary people who had been touched by his work. The man who had spoken for Earth had fallen silent. The immediate aftermath of his death included commemorations and retrospectives that emphasized the scope of his influence. Asteroid 4709 was named Sagan in his honor, and the Mars Pathfinder landing site was named the Carl Sagan Memorial Station. These recognitions placed his name literally among the stars. He had spent his life explaining. Anne Druyan continued his legacy after his death, working to complete projects they had begun together and to extend his influence to new generations. The film adaptation of Contact was released in 1997, introducing his ideas to audiences who might not have read the novel. In 2014, a new version of Cosmos premiered on the Fox network, hosted by astrophysicist Neil deGrasse Tyson and executive produced by Anne Druyan, among others. The series updated the original's content for a new era, while maintaining the spirit of wonder and accessibility that had characterized Sagan's work. The new cosmos demonstrated that the approach Sagan had pioneered remained viable and valuable, that audiences still responded to science presented with passion and clarity. Tyson, himself an accomplished science communicator, carried forward the tradition that Sagan had established, introducing a new generation to cosmic perspective. The books Sagan wrote continue to sell and to find new readers, their insights remaining relevant despite the advances in scientific knowledge since their publication. Pale Blue Dot and the demon-haunted world in particular have achieved a kind of classic status, assigned in courses and recommended in reading lists and given as gifts. The influence of Carl Sagan extends beyond those who knew his work directly, shaping the culture of science communication that has flourished since his death. Science documentaries, podcasts, YouTube channels, and other media owe a debt to the model he established. The demonstration that science could be presented accessibly without sacrificing accuracy. Scientists who take time to explain their work to non-specialists, who write popular books or make public appearances, often cite Sagan as an inspiration and a model. He showed that such activities were possible and valuable, even if some colleagues continued to look down on them. The cosmic perspective he championed has become more widely shared, the recognition that understanding our place in the universe should inform how we live. This perspective appears in discussions of climate change, of space exploration, of human unity across national and cultural boundaries. His skepticism about pseudoscience and his advocacy for critical thinking have also found continuing relevance, as the challenges he identified have only intensified in the age of social media and widespread misinformation. The tools he offered for evaluating claims remain as useful as ever. Carl Sagan's voice survives in recordings and videos, still introducing new listeners to the wonders of astronomy, still articulating the cosmic perspective with the gentle enthusiasm that made him unique. The original Cosmos remains available, slightly dated in its visual effects, but undimmed in the power of its presentation. Young people who were not yet born when Sagan died in 1996 discover his work through the internet, through libraries, through parents and teachers who remember watching Cosmos when it first aired and want to share that experience with a new generation. The voice that spoke to 500 million people in 1980 continues speaking, the words unchanged even as the audiences renew themselves, decade after decade. The original Cosmos series has been remastered and re-released, its visual effects updated while preserving the narration and structure that made it powerful. Viewers who encounter it for the first time often express surprise at how relevant it remains. How the questions Sagan addressed about humanity's place in the universe, about the value of scientific thinking, about the dangers facing civilization, remain the questions we still face today. Good science communication transcends its era because it addresses fundamental matters rather than transient concerns. Sagan's books remain in print, still finding their way into the hands of readers who have not yet discovered them. Pale Blue Dot sits on bookshelves alongside Cosmos and the demon-haunted world, waiting for the next curious mind to pick it up and encounter ideas that might change how they see the universe. Libraries continue to stock these volumes, teachers continue to assign them, and bookstores continue to sell them, because people continue to want what Sagan offered: wonder combined with understanding. The influence of Carl Sagan extends beyond those who engage directly with his work, shaping a culture of science communication that has flourished in the decades since his death. Scientists who might once have considered public engagement beneath their professional dignity now recognize it as essential, as valuable, as part of what science owes to the society that supports it. Sagan helped to legitimize science communication as an activity worthy of serious researchers. Neil deGrasse Tyson, perhaps the most visible science communicator of the current era, has spoken frequently about Sagan's influence on his own career and approach. Tyson met Sagan as a teenager when the established scientist took time to encourage a young person interested in astronomy, a gesture of generosity that Tyson has never forgotten and has tried to replicate in his own interactions with aspiring scientists. The chain of influence extends from mentor to student across generations. Tyson hosted a new version of Cosmos in 2014, subtitled A Space-Time Odyssey, and another in 2020 called Possible Worlds. Both series were produced in collaboration with Drowsy and explicitly position themselves as continuations of what Sagan began. The visual effects were updated for a new era, but the spirit remained the same. The conviction that science is fascinating, that the universe rewards curiosity, that complex ideas can be communicated to general audiences without condescension. Other science communicators carry forward aspects of Sagan's approach, even when they do not explicitly cite him as an influence. The style of science communication that treats audiences as intelligent partners in exploration, that balances factual content, that finds poetry in precision. This style owes much to the example Sagan set when science communication was less developed as a practice. Drowsy, Sagan's widow and creative partner, has devoted the decades since his death to continuing the work they shared. She served as a producer and writer on the new Cosmos series, ensuring that the vision she and Sagan developed together would reach new audiences in forms appropriate to new media. Her commitment to his legacy has kept the Cosmos project alive and evolving. Beyond Cosmos, Drowsy has continued to speak publicly about science, about wonder, about the importance of the perspective that she and Sagan articulated together. Their partnership was both personal and intellectual, a collaboration that produced work neither could have created alone. The books written in Sagan's final years benefited from her contributions, and she has spoken movingly about the process of working with him as his health declined. The Voyager spacecraft, still traveling outward through space, still carrying the golden records that Sagan helped create, have become part of his permanent legacy. Voyager 1, the most distant human-made object, continues its journey through interstellar space, its record of Earth's sounds and images intact, waiting for an encounter that may never come, but that represents something important about human aspiration, regardless of outcome. In 2012, Voyager 1 officially entered interstellar space, crossing the boundary where the Sun's influence gives way to the broader environment of the galaxy. The spacecraft that carries humanity's message to the cosmos has now begun its true interstellar journey, traveling through the space between stars toward a future we cannot predict. Sagan did not live to see this milestone, but he understood when the spacecraft launched that the journey would outlast him. The pale blue dot photograph, and Sagan's reflection on it have taken on a life of their own, shared across social media, quoted in speeches, referenced in discussions about environmental protection and human unity. The image has become iconic, one of the most reproduced photographs in history, not because it is technically impressive, but because of what it represents and how Sagan articulated that meaning. When people quote Sagan's words about the pale blue dot, about the mote of dust suspended in a sunbeam, about everyone you love and everyone you know and everyone you ever heard of living out their lives on this tiny speck, they are participating in a tradition of cosmic perspective that Sagan did not invent, but that he expressed more powerfully than perhaps anyone before or since. The words resonate because they capture something true. The environmental movement has adopted the pale blue dot as a symbol, a reminder that Earth is the only home we have, that there is nowhere else to go if we damage this world beyond repair. Sagan's message about the fragility and preciousness of our planet aligns with growing awareness of climate change and ecological destruction, giving his words renewed relevance to challenges he anticipated but did not live to see fully develop. Space agencies around the world have embraced images of Earth from space as tools for inspiring both wonder and responsibility. The overview effect, the cognitive shift that astronauts report when seeing Earth from orbit or beyond, connects to what Sagan was trying to evoke through words and images. He wanted everyone to experience that shift without needing to leave the planet, to understand our situation through imagination informed by knowledge. The scientific fields that Sagan contributed to have advanced enormously since his death, in ways he would have found thrilling. The discovery of thousands of exoplanets, worlds orbiting other stars, has transformed the question of extraterrestrial life from speculation to active investigation. Sagan spent his career wondering whether other worlds might harbor life. We now know that other worlds exist in abundance and can begin to characterize their atmospheres and conditions. The search for life on Mars continues, with rovers exploring the surface and future missions planned that will look specifically for biosignatures. Sagan's early work on Mars, his contributions to understanding what conditions might exist there and what signs of life might look like, helped establish the scientific framework that guides current exploration. The questions he asked are now being answered, or at least addressed, by instruments he helped inspire. The search for extraterrestrial intelligence has continued as well, expanded by new technologies and new approaches that Sagan could not have anticipated. Radio telescopes scan the sky for artificial signals, while other researchers look for other signatures of technological civilization. The Breakthrough Listen project and other initiatives carry forward the scientific program that Sagan helped legitimize when it was considered fringe. If life is ever discovered beyond Earth, whether microbial life on Mars or Europa, or intelligent life sending signals from distant stars, the discovery will vindicate Sagan's conviction that the search was worthwhile, that the question was worth asking, that humanity should look outward with curiosity, rather than assuming we are alone. He may not be present for that discovery, but his influence will be felt in its meaning and its reception. The skeptical tradition that Sagan represented has become more important as misinformation and pseudoscience have proliferated in the digital age. His book, The Demon-Haunted World, reads as prophetic now. Its warnings about the consequences of scientific illiteracy, borne out by events he did not live to see. the tools of skeptical thinking that he advocated, demanding evidence, questioning claims, recognizing logical fallacies, remain essential for navigating a world awash in competing claims. Science educators continue to use Sagan's baloney detection kit, his informal guide to critical thinking, as a teaching tool for helping students evaluate claims. The principles are simple but powerful. Ask for independent confirmation. Encourage debate. Check whether the hypothesis can be tested. Consider alternative explanations. These tools protect against deception and self-deception alike. Yet Sagan's skepticism was never cynical, never dismissive, never hostile to the human needs that pseudoscience often exploits. He understood that people turn to astrology and UFO beliefs and other unfounded ideas because they offer wonder, connection, and meaning. His solution was not to mock these needs, but to show that science could satisfy them more honestly and more deeply. The wonder that Sagan offered as an alternative to supernatural belief remains available to anyone who looks up at the night sky with understanding. The stars are not gods or omens, but nuclear furnaces converting hydrogen to helium across vast distances. And this truth is more amazing than any mythology. Sagan made this case repeatedly, always gently, always with respect for the human hunger for significance that he shared. The style of presentation that Sagan developed, calm, enthusiastic, accessible, poetic, has influenced science communication across media. Documentaries about science often echo his approach, even when they do not mention him by name. The assumption that audiences want to understand, that complex ideas can be explained without dumbing them down, that wonder is the appropriate response to the universe. These assumptions, now common in science media, owe much to the example Sagan set. His willingness to address philosophical and existential questions alongside scientific ones expanded what science communication could be. He did not pretend that science was neutral on questions of meaning, did not avoid the implications of what we know about the cosmos for how we understand ourselves. Science revealed that we are part of the universe, made of the same stuff as stars, connected to all other life on Earth through common ancestry. And these revelations have meaning. The phrase "we are made of star stuff," which Sagan popularized, though he did not originate it, captures something profound about the relationship between humanity and the cosmos. The atoms in our bodies were forged in the cores of ancient stars that exploded billions of years ago, scattering their material across space to eventually form new stars, new planets, new life. We are not separate from the universe, but expressions of it. Matter become conscious and curious about its own nature. This perspective, at once humbling and exalting, remains one of Sagan's most important contributions. He helped people understand not just facts about the universe, but what those facts mean for who we are and how we should live. Science in his hands was not dry or disconnected from human concerns, but intimately relevant to the deepest questions we ask. The institutions and awards that bear Sagan's name ensure that his memory persists within the scientific community. The Carl Sagan Medal, awarded by the American Astronomical Society, recognizes excellence in public communication of planetary science. The award exists because Sagan demonstrated that such communication matters, that scientists who engage with the public deserve recognition rather than dismissal. The SETI Institute continues work that Sagan supported, searching for evidence of intelligence beyond Earth, with methods more sophisticated than any available during his lifetime. The search has not yet succeeded, but neither has it been abandoned, and its continuation reflects the conviction Sagan helped establish that the question is worth pursuing, regardless of how long the answer takes to find. Educational programs and initiatives invoke Sagan's name and example, encouraging young people to pursue science and to see it as an adventure rather than a chore. His ability to inspire remains valuable, a resource that educators draw upon when they want to show students that science is not merely useful but genuinely exciting. The crater named for him on Mars, the asteroid bearing his name, the various honors bestowed during his life and after his death, all of these acknowledge a contribution that transcended ordinary scientific achievement. Sagan was not honored simply for discovering things, though he contributed to discoveries, but for changing how people think about science and the universe. The night sky that Sagan loved remains available to anyone who steps outside on a clear evening and looks upward. The same stars that ancient humans wondered about, the same questions that have occupied curious minds for millennia, await each new generation that takes the time to notice and to ask. Sagan did not own these questions or these wonders. He simply helped people appreciate them. The cosmos does not require interpreters, but good interpreters help us see what we might otherwise miss. Sagan's particular gift was making the invisible visible, the distant near, the abstract concrete. He took facts about the universe and made them feel real, made them matter to people who might never have cared otherwise. His message, ultimately, was one of invitation. The universe is not hostile or indifferent, he suggested, but fascinating and worth exploring. We are capable of understanding it if we apply ourselves, capable of discovering truths that previous generations could not have imagined. The scientific enterprise, whatever its frustrations and limitations, offers genuine knowledge about genuine reality, and that knowledge is beautiful. The invitation remains open. The questions Sagan asked are still being asked. The universe he helped reveal is still being revealed. Each generation of scientists and science enthusiasts pushing a little further into the darkness, illuminating a little more of what was previously unknown. The work continues, and in continuing, honors the memory of those who came before. As this evening draws toward rest, the thoughts of Carl Sagan and his legacy can settle gently, becoming not information to retain, but atmosphere to inhabit. The cosmos he described continues existing, whether we contemplate it or not. Galaxies spinning and stars burning, and planets orbiting in the same silence that has accompanied them for billions of years. The pale blue dot still orbits its ordinary star in an unfashionable arm of an ordinary galaxy, still carrying the only life we know of in all the vastness of space. The responsibilities Sagan articulated remain. The fragility he described is still real, but tonight these truths can rest alongside us rather than demanding action. Somewhere, right now, a young person is encountering cosmos for the first time, is reading one of Sagan's books, is hearing his voice and feeling the wonder he communicated so effectively. The chain of inspiration continues. Each generation passing to the next the questions and the attitudes that make science possible and worthwhile. The stars outside your window, if you can see them, are the same stars Sagan pointed toward throughout his career, inviting audiences to look up and to think about what they were seeing. They are nuclear furnaces and distant suns, and potential hosts of planets, where other minds might someday wonder about the cosmos as we do. They are also simply beautiful, points of light in the darkness that have inspired human beings for as long as there have been human beings to be inspired. Carl Sagan spoke for Earth because someone needed to, because the perspective from space revealed truths about our situation that we could not see from the surface, because science had given us knowledge that deserved to be shared. He spoke clearly and gently, and with genuine love for both the subject and the audience. His voice is quieter now, but not silent, preserved in recordings that new listeners continue to discover, embedded in a culture of science communication that he helped create. The work he began continues through others who carry forward aspects of his vision, each contributing to a growing understanding of the cosmos and humanity's place within it. The universe remains as vast and as wonderful as it was when Sagan first looked up at the stars as a child in Brooklyn, wondering what they were and whether anyone lived among them. The questions remain open, the exploration continues, and the invitation to wonder extends to anyone willing to accept it. Tonight, the invitation is simply to rest, carrying whatever thoughts of cosmos and Earth and the man who spoke for both feel worth carrying into sleep. The stars will still be there tomorrow. The questions will still be there. The wonder will still be available to anyone who seeks it. Good night from the Drowsy Astronaut. Sleep well, and we'll explore the cosmos together again soon.